cool. Cool. Okay, looks like we're live. Sweet. How to walk 12 miles a day. Alright, interesting. Hole-in-one insurance. Oh, okay, this one's gonna be good. Okay, let me see if I can zoom this in. Sweet. Alright, cool. Strange. Oh, this is basically like reinsurance and really, really high, um, risky, unlikely events. Actually, that's kind of cool. I think this is pretty much the same as insuring against crazy, um, events like hurricanes. Hey, Justin, what's up? This is okay. Anyone is stuck a hole, 1 million. Hole in one, $1 million. The insurance firm that have been hiring, that have been hired by the organizers. What? Oh yeah, yeah. This is a reinsurance. This is basically the reinsurance business, actually. Okay, I know what he's talking about. Hole in one insurance. Blah blah blah. Okay, I think. Okay, I can pretty much talk. Okay, I think I know what this is talking about. Yeah, yeah, the stats don't really matter. It's basically a huge discussion on tail risk, actually. So if you understand what tail risk is and you understand what offloading that tail risk means, you pretty much understand the hole-in-one insurance thing. It's like basically insuring against like a hurricane or something. Let me see. Let me see if I can find like a quote in here that might like capture this idea very well. But then like why is this very specifically for hole-in-one insurance? What makes it different from like say hurricane insurance? Like how do you predict the probability of getting a hole in one on a particular golf course? Relatively small fee. If someone gets a hole in one, covers most of the prize. Okay, yeah. Blah blah blah. The cost to insure against a hole in one depends on factors: number of golfers in the tournament, the length of the contest hole, and then the cash prize. Okay, that's fine. Plugged into an algorithm and spits out a dollar amount. Ooh, I feel like this is highly abusable, actually. If it's an algorithm, I think what they did is just they took all the they just based on those three factors they ran like some machine learning linear regression or something, and then they basically back test, and then they just basically said, oh yeah, based on this historic event, this is like our dollar amount that we're gonna give you. So I don't know. Shouldn't you also take into account the quality of the golfers themselves? Because like there's a difference between having 100 amateur golfers and then 100 like pro level golfers like 100 Tiger Woods. The price of the insurance would increase if you have the skill of the golfer increase. Okay, yeah, yeah. So insurance firms operate on the premise that the odds of something happening are small enough to assume a repeated risk. Yes. Hole in one are fairly small. Yes. They're saying exactly what I just said. The amateur golfer versus the pro golfer, you have basically 4 times odds. The pro golfer, 400 million rounds of golf are played each year. You're gonna have at least one guy get there. Yeah, that's fine. So what happens when someone wins? Yeah, I get this. Okay, okay. So he insures 50,000 events and pays out hundreds and hundreds of hole-in-ones. Gets dinged up pretty bad. All right, sure. Yeah, yeah. These are the black swans. Okay. They set him back $300,000. Fine. Payout for $1 million prizes. Steep cost. Or... Okay, before paying out a prize, you require a non-participatory witness. Gentle investigation of legitimacy. Frauds do happen. Yes, of course. So my question is, how profitable is this actually? Like, because you're basically taking on small no events, and then when a big event occurs, you take on a big loss. So my question is, how good is the model, and how much like money are they actually making? I'm very, very curious. If you can dream it, I'll insure it. Okay, this is interesting. Okay, he's insured a bunch of this crazy stuff. Yeah. Bless me. Okay, so these are like I'm quite curious. How the hell do you calculate these probabilities? Like throwing a frisbee through the sunroof of a car. how do you calculate the probability on that shit? If the cow poops on a pre-selected number, the person wins a prize. Does anyone know how the fuck to calculate these odds? I don't know. If anyone in the crowd knows how to calculate these crazy freaking events, let me know. Like tossing a cookie into a bowl of milk. Where do you come up with these fucking odds? How do you calculate this at all? Okay, so all these things are insurable because they fall into mathematical, skill-based, or odds-based. Okay. He uses rough chance and uses data to compute his premiums. Insure things. He has to recreate the scenario himself. He'll recreate it himself with the results. Okay. I mean, this is basically the reinsurance business altogether. And it's just like, in reinsurance, if you're like saying, let's say you want to insure a town against a hurricane, you just need to know, like, your lines of exposure, right? And so once you can individually identify those lines of exposure, you can come up with your risk premiums. But the thing is that if, like, say there is a macro event, like an act of war, well, everything is gonna fucking happen, right? So for instance, let's say I have insurance for fires, right? But then usually in those insurance, fire contracts, they usually will say, hey, we will pay out except in an act of war. Because in war, anything fucking happens. Things get blown to bits, everything gets on fire. And so if you are someone insuring that and an act of war occurs, then you basically get hit with all those different events and all those different insurance contracts, right? And so that's why that clause is there. So it's like just this kind of this kind of business. It's always like the calculating lines of exposure and just like trying to reduce things that would blow up multiple lines of exposure all at once. And so this is like relatively simple compared to like predicting the payout of a hurricane. But I still don't understand like why you would just throw data at it. I mean, in theory, it's just like, okay, I calculate the odds of this actually happening. I calculate the black swans, and then I just go for it, right? But it still doesn't make sense to me because how do you know you're not estimating the black swan? Because fundamentally, by definition of black swan, it can only happen one in every blue moons. So how do you know you've run enough trials to make it statistically significant? I don't know. Anyway, let's bring on my client, and then we'll chat later, guys. Oh, hi, Bucket Sort, and hi, Alvin. Okay. Hello? Hello?
Hello?
Yeah, I can hear you. Can you hear me?
Perfect.
Cool. Yeah, man. It's been a week. How's everything
been a
been?
week. Um, yeah, I'm a little bit tired to confess.
Yeah.
Because school, adding the job, adding the training. But yeah, training is the main priority still. Yeah.
That makes sense. Yeah, I mean, like we have we just have the 20th to look forward to. That's our goal. So all I'm asking is just like for 17 days, like 3 weeks of your best effort.
No, for sure. I'm totally on that
You
mindset.
get this. School doesn't fucking matter anymore.
No, for sure, man. I think to myself, from the half of the semester, I can deal with the things it's kind of that I didn't solve like in this first portion of the semester, but it will worth in the end of the day, for sure.
Okay.
Anyways, yeah.
Okay. So cool. Let's talk about like I see you stuck me a few notes here.
Yeah.
And so I kind of want you to like kind of walk me through what you've been doing for the past week, because I remember we were talking about like trying to find these heuristics to make you faster. And I know that we've been running into that a little bit of that wall where it's like, okay, well, remember the what's called the serialize and deserialize portion. And I remember mentioning to you, hey, yeah, my odds are very good at solving this problem because I know XYZ things are happening. What have you been doing to kind of get there? Let me ask that.
One thing that I've been doing is like for some of the questions, I've been practicing like, just trying to do my best, focusing those heuristics, right? But just to, for a matter of benchmark, I've been tracking my time just to see how that goes under time pressure.
Okay.
And there's one point I put on the bads, unfortunately,
Okay.
that actually me and my friend, we perceived that I am having a tendency of like, I missed few details when I'm like looking to my time, you know. When I see that I'm 30 minutes in and I'm in the last test portion, and I kind of do some confused stuff.
Yes.
More when I am on the rush, you know.
Yes.
Then, and like just for comparison, we did a mock interview last week, you know, and the question was not so trivial, so there was a little bit thought process involved. But I was totally calm, like not under time pressure, you know. I was able to finish in the time, like doing the heuristics we talked about like last week, and was kind of, I'd say that 9% good, you know.
What do you mean 9% good?
I mean, like with no major mistakes, like all the points were clear to him, you know. And but when I am just by myself, you know, just training, like under time pressure, when I set the clock and like the clock is counting down
Yes.
my time, I'm kind of feel that I'm rushing, you know, and I pass over those details, which it's not good, you know. Like for example, he pointed out in the last video I recorded today, because I had like 40 minutes before go to the class, so I knew that I had those 40 minutes to solve the question.
Yes.
And he said, like the whole idea was good, like the solving the problem was good, but there was few details. I perceived that you make like more uncertainty while you're solving the problem, you know.
Yes.
So a few things you have to go back. That was not the same behavior you had in our past mock interviews. Like all of them, basically, I didn't feel this. And when you are in a rush, I perceived this behavior happen over and over.
Yes.
So basically, I think that is the main highlight, as you just did
Yeah.
from the whole practice. Yeah.
I understand. And I'm gonna tell you this: no one ever gets rid of that time pressure. So what I mean by this is that there's always gonna be time pressure, right? But the moment
sure.
you become exposed and aware of it, and it actually starts, you know, like you feel pressured from it, it will always affect you. It's always happened to me. It's always happened to anyone, even at like, you know, any company you work at on any large scale project. The moment you put pressure on someone, and people like, and in a bad way, it will always affect their performance. You never get rid of this. You never get over it. And that's why I was kind of against you like looking at the clock when doing these. I think I mentioned in the past, don't worry about the time. Worry about getting the answer right in a very what's it called, relatively strong and robust way that, you know, where you don't like lose efficiency, and then look at the clock, and then after that worry about it. It's a very difficult thing to do because I understand the more you look at the clock, the more you're just like, oh my god, I need to do XYZ, I need to make up for the time. And that's where we basically call this, it's like risk, it's leverage essentially, where it's just like, okay, let me start cutting corners so I can meet the time. And that's usually one of the worst things you can do in an interview, because like, you know, you're like you said, your friend recognized you were already in the right track. All you need to do is just make one simple clean cut towards the end. You don't need to make like a bunch of like mistakes and missteps, because once you start cutting corners, you miss that one little detail or one misstep, it sets you back like double time or triple time. And so I think for the most part, the goal is to always aim for a answer, right? And make sure that the answer is correct. But if you don't quite make the time, but everything else leading up to it is logical, not really inefficient, the interviewer will completely understand. He's just like, okay, I see you're like checking off, you're being careful. I will give more points to someone who's careful and obviously going to get the answer by giving like 5 more minutes than someone who's rushing, cutting corners, and I'm not sure if he's going to be able to get the answer at all. Or even if he gets the answer, it's like, oh wait, you're kind of taking a lot of risk here. I don't know.
Yeah.
You think about XYZ, you know? And that's really an important point. It's really hard to get into one's head. And I can give you an argument for why it exists. I can't give you an understanding until you felt the pain of simply cutting corners and it blowing up in your face. You kind of need to basically like feel that pain and have that pain burn into your brain so badly that you will never want to make that mistake again. It's just something to recognize that yeah, you can rationally understand it, but it's the instinct. Because again, like I said, you never really get over it. It's just human instinct. So let's see.
It's just like put the hand on the fire, you never knew until you get burned.
Exactly. Someone can tell you don't touch the stove, but you're, but you've never had that experience of touching the stove before, so, and like as a kid, and so you're like, oh, what happens if I touch it?
Yeah, never touch again. Yeah.
Exactly. So that's where like experience and mistakes come in, and it should teach you like not to rush it. So let's see what else we have here.
Can I just put one more point here?
Yes.
Like about our last mock interview, right?
Yeah.
The problem was to calculate squares inside a matrix, like n by n matrix, and was kind of complex to solve,
Okay.
Like was one point that I put as a bad because at the beginning my idea was totally clear for me,
Okay.
I tried to draw it out the idea for him.
Yeah.
But he was I felt that he was having a hard time to understand what I was trying to communicate. All of our mock interviews is in English, by the way.
Okay.
And in the half of the interview, I think was 25 minutes in, when I was like doing my final test,
Yeah.
he doubt of my algorithm,
Yes.
and he thought this is not gonna work, but I was totally sure, no, this is gonna work. And on this last explanation, he understood. He said that in a like his feedback that in a re-interview this might count as good points because like I was able to prove my idea that was correct. But I count this as a bad point because I was not clear in the first time, Maybe that's a lack of understanding of him, lack of attention the first time. But I put this on my shoulder because I was not clear in the first time. So that's the point I'd like to tell you as well.
That's fine. And I'd rather you be in that situation than to, like fucking do like random shit, right? I'd rather you be in a situation where it's clean, it's methodic, it's easy, and it's very clear to you. All that's left is really to make sure or that you adjust it a little bit to bring it to the interviewer and make him aware of it. And this is why like I recommend examples. And so we'll look at that later. I kind of want to get through like all this bad and good points that you mentioned before, but it's good that you acknowledge this and you're able to recognize, hey, yeah, if I'm losing the interviewer, even though my idea is clean, it doesn't count. So,
Yeah.
I
Because
would
he
say
would
right
doubt
now
of
that means basically it's just your communication. If your framework is going to get you to the right answer very consistently, then all that's left is really how you talk about it.
Yeah.
So let's see. Focus on
Okay.
thought delta. Yes. Okay. This one I remember I was harping on you about. How has that?
Yeah. One thing I noticed is that for a few questions, like I was trying to go in a much more complex way, and for this, my answer, I have a clear example for this, was one of to recognize where the lists overlap, two linked lists overlap.
Okay.
And I was thinking about like a crazy thing of invert the linked list because it was the first tool I thought.
Okay.
But it was much more simple than this. It's like just traverse and see where they meet, something like this, where the references overlap.
Okay.
So I focus on the thought, the delta thought, right?
Yes.
Of the book. And a few of other questions I felt the same tendency of me trying to like overcomplicate a few details that the book does with in a much more concise way, So they use like even if it's like declare the variable, two variables in the same line, I feel that's much more concise than yeah. Anyways.
I'm gonna say don't
Those
worry
are
too
the
much about the
points.
syntax. I mean, it's the core idea underneath that matters.
Oh, actually, there's like two questions if you want to see like in practice. I put on red on my diary,
Okay.
like to get the max, actually to implement an API of a queue or a stack. I think one of those two. I don't remember by the top of my mind.
What row is this?
Let me just.
Oh, is this
it's like 237.
237? Okay.
Yeah, 237, and yeah, actually the 242 was a little bit. I had a little bit struggle as well. And yeah, for this Kill with Max API, I had like almost the optimal solution, but was one step before the optimal. So there was the most brute force, the middle one, and the optimal. I was in the middle one.
Okay.
And then I like looked to the book and I took note on the diary.
Cool.
Like was just a trick that To be honest here, I could spend like 1 hour in this exercise, and I was not able to figure out that logic of like having portions of the list of the queue in another cache.
That's fine.
It was kind of not clear for me. Yeah.
Okay, that's fine. As long as you got pretty close, you understand like, hey, this is a really weird detail. That I never would have thought of. Yeah, I'll look at that. That's something for me to look at, see if it's intuitive or not intuitive, if it was logical to get there or you fucked up, you know. But I think I have
Okay.
points to look at. So let's go ahead and kind of like talk about the first one. The first one that you mentioned that hey, you lost the interviewer, right?
Yeah.
So it's the one that you put in week 13.
Week 3. Oh no, that one is the one I recorded today.
Okay.
Just to so you can see where I'm at,
Okay.
like in terms of efficiency. But it's the first one, in the first page of the problem sheet.
Okay, let's see.
Like the exercise name is.
Matrix square.
Sorry, I haven't highlighted for you,
That's fine.
like the name of the exercise.
Is it the maximum
But-
square one?
Yeah, the maximum square one.
Okay.
Yeah.
Let's read it together. Given an n by n binary matrix filled with zeros and ones, find the largest square containing only ones and return its area. Okay. So this I see here. So this top one is just the example. So you decided. So this first no empty matrix. Okay, you do the balance of the problem. Yeah. So this one is for because you. Wait, can you give me edit access actually? I need to break it up. I need to break up the example here. It's kind of hard
For
to
sure.
see. So
Just a minute, editor. I think you have the grants now.
let me go ahead and refresh the page. Cool, perfect. Yeah, I'm gonna mess this up a little bit just so I can actually see it this myself. So yeah, so you have this, and no, and then this. Okay, cool. And so the reason why it's 4 is because you have this here. And you're looking
You need
very
to take this
specifically for a
course.
square.
Mhm.
Okay, cool. All right, so let's see.
The greatest one, the biggest one, yeah.
Perfect. Yeah. So then minimum error 3, 4. Okay. So yeah. I like this. Fine. You're just declaring the bounds of the problem. You try running through an example just to make sure things don't work. So your idea first is to traverse every cell in the matrix. Let the minimum between height and length be x. Okay. So the minimum between height and length.
Yeah, it's just because I can know where, like, how big can be my square, you know? So I have to take one of the limits, that is, or the height or the length.
Okay,
you know?
so you're gonna take the minimum of height and length to be x. Okay, height and length of the square you're currently looking at, right?
No, the matrix, the entire matrix.
Okay.
So I just can put a bound, like a limit. I cannot have a square greater than this, you know?
Sure.
Because I can have a rectangle in a square, you know? A square in a rectangle.
Okay, got it. Okay, so I understand that. So for every cell traversed equal to 1, try to form a square until no 0 is found. Okay, so this bottom part here is you trying to create a square off of every single one. Okay, that's fine.
Yeah, it's kind of brute force, but yeah.
Fine, that's fine. Take the minimum height between height and width of the matrix. Okay, height and width of the matrix, right? Okay. For every I between 0 to n minus 1, j n minus 1, for current cell, if current cell value equal 1, then the local area is da. So then you take x and j, sure. So you take your current index, fine. And then while counter is less than x or 0 found is false. Okay, I see what you're doing here. Okay,
Yeah.
so you take every single. Yeah, I can see why he might have gotten confused, but I think for if you like, maybe clean up the. I think it's just cleaning up the language, but I understand what you're trying to do. You just go through every single one of these ones that you have, and then try to grow a
Yep.
square from that.
Sure, that's it.
That's basically.
And
it.
when it's not valid, yeah, that's the idea.
Yeah, so there's a little bit of language here, but it's like, it's not incorrect. Let me put it that way. It's not incorrect. The idea is not incorrect. It's just that there may be a little bit of communication confusion, but it's not. It's just cleaning up a language a little bit, like I just did here. Okay, so then for every single row between k0 to minimum of row and the counter, for row of L and the counter, then you recurse in. Okay. Let's see. Why is this not sitting right with me? So your counter. Why do you have a counter? Let's first ask that.
A counter is to try all the possible squares. So for example, I'll first gonna try a 2x2 square. Then I'll increment the counter. Then I will try 4x4, you know, until my limit. That's pretty much it. Until
Where
it's
do you
valid to.
Okay, well, where do you increment counter though?
Oh yeah. That was a bug that I took note on the code itself.
Okay, I see.
That was a detail I missed.
Yeah. So okay, okay.
Because I used the 4 as well. On the actual code, I used the 4.
Okay, actually, let me look at your final code here, because I can see why there might be some confusion here, because this is not immediately obvious to me. So
that's the code.
I'm gonna jump straight to your code because I understand you have the idea here, right? And so you're trying to grow, and can you find a 2x2 square on each side, 3x3 square, 4x4 square? I get it. But so your K and L. Where does K and L come from?
Oh, the K and L. It's a little bit confused because of this. I broke into 2 functions. The K and L is just the 2 indexes. Like they are analogous to I and J. You know, like the I and J is where I'll try my ones, and the K and L is where I will expand. I will grow. You know, the square.
I see what you're doing. Okay, I understand. So this counter is basically just the square you're testing for. It's the size of the square you're testing for. That's basically what you're doing.
Exactly.
Okay, so that's the first thing. It's like the name of the variable kind of sucks. That's probably the first thing here. I can see why.
It should be length of the square.
Yeah, and notice like yeah, you should say like what this variable represents, etc., etc. So again, your plan is fine. It's just that it seems to resemble a little bit too much of code for my tastes. I think that might be where some confusion comes in. And again, like remember what I said about like English sentences? It's like right now if you look at this, does a 5-year-old understand it? Like why is this here? Why is this here? Why is this here? Right? So
I tried to do this on the plan, like before the plan actually.
Yeah. So it's
and
like,
here's the pseudocode.
Yeah, I see. So you traverse every cell. Let the minimum between height and length of the matrix be x. Okay. So for every cell traversed that equal to 1, try to form a square of size x, or at most, or at from size 0 to x. Here, let me like from size 0 to size 1 to x. Try to form a square for size. Here's the thing. So let's say this is probably what I would add, and it makes a little bit more sense. A minimum height and length of the matrix x. So now like it's a little bit more clear here. But then like to me, the question then becomes, okay, well then if I do that, then I have to grow it in all 4 directions, right? So you know I have to go from right and down, and then from left and down, and then left and up, and then right and up, right?
No. I was just assuming that I can grow to left, like just to left, bottom, you know?
Okay.
Just starting a traversal, like just a normal array traversal from the elements that I'm at, you know? So for example, here you are in the row 0, you know, and column 1, okay? Then I'll go to column 2 and like in a 2x2, you know? And then, that's the logic.
Okay, that's fine.
Not all the sides. I consider all the sides, but I thought that I need to use recursion. That was not where I wanted to go. Yeah.
So you're aware of this, and then as long as you communicated that, because like that's what naturally the interviewer would say, and if you just came with me with that, I think you could the way you explained it, you could clean up a little bit. You could just the way I would say it is because we're traversing from left to right and then from top to bottom, we don't need to go in the opposite directions at any point. Because if we did find something going from left to up, we would have found that starting from the left-hand corner going down. So like for instance, if let's say I was at this one, right? You're saying that because eventually we will have, if we found like a square that's say from here to here and here to here, because we're going from left to right and top to down, we would have found that same square just starting here.
I missed that last point while explaining.
Yeah, so that's basically what I think you're saying. So like say for instance, if this was the answer, well we don't, and we ended up being here. We don't need to go from bottom to top left because we would have already found the square just starting here.
Yeah.
Yeah. So you see,
I was not that clear about it.
Yeah. See, this is like where being very simple with your thought and being explained it very clearly, I think would have saved you a lot. I mean, again, it's a skill, but it's like it's there. I'm just kind of showing you. Here's the way I would have explained it, and then it's like kind of your job to say, okay, here's how Edward would have explained it. How can I do it? Because you understood it when I said it, and all I do is just like
In the
highlight
first
it
moment.
and explain it.
Yeah. Yeah.
So it's a skill. Don't get me wrong. But that's something like we're trying to work on here. So okay, that idea works. I have no problem with it. But then I would say it seems slightly inefficient. Actually, do you know why?
Yeah. Because I will, for example, as you pointed out, for this square, for example, I already calculated,
Yes.
then probably there should be a way where I kind of marked like the ones I visited, like just to not be inefficient, and something in this thought process, something in this line of thought. Yeah, I guess he said that there's a more optimal solution using recursion, like actually dynamic programming.
Okay.
In which you kind of memorize the things you've already visited.
Yes.
But I haven't tried to implement, to be honest here.
Okay, that's fine. I would say if you got to that, your answer works. I think it's fair to say that if you got this in 30 minutes, I think it's fine. I think a 30-minute mark is fine. How long did it take for you to do this?
I think probably between 30 and 35, because we are discussing this point in the end, which took a little bit of the time, but nothing more than 35.
I would say, yeah, I think you did fine. Explanations could work. I could do a little bit more work. I would also say that, yeah, it's mostly just revolves around explanation, and I think yeah, you should try the dynamic programming version. Just see why, because remember what we said. Like now that you have the example, like what is the inefficiency, you're recalculating a lot of squares. So for instance, let's say like this was 1 1 1 1 for sake of argument, and you looked at these top 4 squares, then you know that if there's a 3 by 3, it must contain this square.
Yeah, it doesn't make sense to revisit again.
Yeah, so it's fine. That's where the discussion would have headed. I think that I would have given, based on what I hear, I would have given you a B to a B plus on it, simply because there's a lot of time that probably got wasted because of the explanations, or lack thereof. And I think that
if you go on the next page, there is also the point where I was trying to explain to him. Yes. I drew asterisks to try to mark this idea that you explained me less than 10 seconds.
Yeah, that's the thing. I'm pretty good at it, to be fair. And like
you are.
But it's because I've been doing this for a while, so it's very difficult for you to like catch up to me. But like, I'm not saying you can't do it. I'm just saying it's hard. So it's just like being able to try and get better. So it's fine.
Yeah.
But
every day.
All I did here was just highlight. That's it. I think you might want to try using that tool, see if it helps. Okay. Other than that, I'm not disappointed, but it's just I think we can do better. Okay, let's look at the one that you told me was what's it called? The sheets that you said was that you had a red mark by it. Let me pull that up.
Let me try to find as well.
Yeah, where is it?
I'm trying to find this thing.
Okay.
Actually, it's much more easier when I highlight.
So yeah, Q with the max API, right?
Yeah, max API. Let me.
Is that in the prompt sheet 15?
16, 15. Yeah, it's on the 15. No, actually, yes, it's on the 15. Implement a queue using an array store. Oh no, that's a circular queue. It's on the 15. Sorry, I was looking to the bottom of it, I guess.
Okay, so it's on page 15. All right, so it's Q.
Actually, it's on the 14. It's in the 14. Yep.
Okay, yeah, so the page 14. Okay, Q with max operation. Okay.
Oh.
All right. Wait, someone said that. Okay, I need to address this one comment. I think in the stream. Loop over rows and calls and do a DFS and keep track of the visit cells. So time complexity row times column. Yeah, something like that. Except for the fact that you need to keep in mind that you can't just like go row what at what's it row 1 2 3 4 5. you have to get one square and then the next square and then the next square. So the 1 by 1, then if that works, then you have to get the 2 by 2, and if that works, then you have to get the 3 by 3. Otherwise, you end up in the same situation that M is kind of in. So that leads you to dynamic programming solution. Gerald, I'm trying to address the comment here. So, okay.
Okay, no problem.
Yeah. So basically,
good.
so I'm telling you right now, you can get the dynamic programming. I think if I gave you like 15 minutes, it depends on how good you are at dynamic programming. But okay, implement a queue with max operation. Implement a queue with NQ, DQ, and max operations. The max operation returns the maximum element currently stored in the queue. Okay, so you need to use a queue with a max. Okay. And you need. And does this mean that the operation has to be backed by a queue? The entire what's it called, the queue itself?
No, you can use other data structures
Everything
like hash, yeah, anything else you want.
Okay, so you thought of using a stack to compute the max. Okay, okay. Interesting. Okay, let's see. So you use a normal NQ through a DQ. But the thing is that Q and DQ, I feel like that's kind of cheating because it's all the difference between a Q and a DQ is just DQ you get double-ended, right?
Yeah, yeah.
So I think that's kind of cheating. I think that kind of breaks the spirit of the question.
No, yeah, like you just no, for sure. Like my idea was to create a normal queue, just using a list in Python, and just actually I will use a deck. Yeah, if you consider this a cheating.
Yeah, I would consider it cheating because essentially all you've done is say I'm going to implement a queue using something that has queue operations and behaves like a queue but has extra stuff on top of it.
No, but yeah, actually this is the first approach. I was not considering this as the final approach.
Okay, I mean, I have no problem with it. I think the interviewer might have a problem with it if he gave you this question. He'd be like, okay, don't do that.
Yeah.
But it's just like kind of a common sense sort of thing. Like, hey, wait a minute, why am I giving you a problem that you can just use one simple data structure for that does exactly what I'm asking?
Oh, because there's one point, as you mentioned, like the core of the problem is the max operation.
Okay.
Maybe they wanted me to focus on the max operation. Maybe that's a thing to ask. I don't know.
Maybe. Anyway, so I don't mind this as a first approach, but then again, the interviewer would probably step in and say, hey, let's not do that. But it's fine. I guess you're kind of doing it on your own. It's kind of hard to tell, but whatever. All right, so yeah, I think you basically, your complexity is space n because, well, if you want to compute the max, you go through the queue and then put it in a stack and find it and then put it back in. Okay, I get it.
Yeah, and then like I went to the most
So you
brute force, like just to search. And then I tried to go in a kind of a binary search tree, just so we can have a log n time complexity while getting the max.
Okay.
But I tried to be very mindful about all the operations,
Holy shit.
Because, for example,
okay, go ahead.
sometimes we can dequeue, and depending of like where the node is placed on the tree, we need to kind of I put a AVL, but I messed up with the term. I tried to explain like just to exclude the node from a tree. You have to do a kind of operations. But yeah, forget about this AVL. It's kind of overcomplicated.
You basically create a self-balancing tree. And I don't know how that helps you because all it is just gonna be like you insert it and then you do those like right left rotations and whatever fuck it is. But I think it does. I think it destroys the order if I remember right. So it destroys the order of the queue because all it is just like whenever you move something up, it just all you're guaranteed is the order and the balance factor. You're not guaranteed. I mean, you're only guaranteed what like left hand side is going to be minimum, right hand side is going to be maximum, and then you're guaranteed some property of the levels, but you're not necessarily guaranteed the order in which you NQ and DQ things. So I think
no, but here's the thing. No, but here's the thing. I'm not using this to create the queue itself.
Okay.
I'm using just to have the max method,
Oh.
So imagine that I'm still with the idea of the deck, and then I'm just trying to improve because the deck give us like all of one time in terms of NQ and DQ.
Okay.
And I was just trying to improve the get max operation because I was focusing on this core problem, So because of that, I tried to use a tree. I first tried to use a heap, but I thought that would be much more complex, because it's going to be n log n.
Yeah.
And which will increase our time complexity. Okay. Then I thought about a binary search tree, but yeah, I couldn't think about anything better.
Okay.
Until I read the solution.
Okay, I see. Yeah, so your inefficiency is still that you actually have to maintain a queue and then you have to maintain a tree.
Yeah.
So you have double the amount of memory. So then, you know what? I'm going to take a bite at this question without, since I haven't looked at it and I don't know what the answer is. I'm going to say that in order to reconcile this, it's simply better to have one simple data structure and to not, have to deal with the complexities of it. I'm going to say that the NQ and DQ, it's okay for us to have order n operation if it means that get max has order 1. So what I would do actually is, I think that, yeah, we want to have one central data structure just to avoid complexity. And you're allowed to use a queue, but let's suppose to say question, you're not allowed to use a DQ, right? So that leaves us with a list tree and then stack potentially and heaps, But the thing is that with trees and the heap is just a tree underneath, and it's not obvious to me how to do that, right? Because you already tried the AVL tree and then balancing it, and I think the tree should destroy the order in which you NQ and DQ. So I'm going to eliminate that because it's not obvious to me. Doing a list is just going to get us it's just basically NQ and DQ right there, so attaching to the front of the list and back of the list. So it's not really any different. So that leaves stack being the only thing left. So if I NQ something into a stack, then the first item I add would be at the bottom of the stack, and then I would be, put as I NQ things. Then the last thing I entered would be at the top of the stack, right? But then if I want to DQ something from the top, from the first thing I did, it's at the bottom of the stack. So I have to pop the entire stock, right? And so what the fuck? How the fuck do I store these things, right? So I once I pop it, I grab the element. Then what? And then how do I put it back into the stack? I mean, I could do that, right? Yeah. So, but the thing is, the idea is store that while I am popping it, right? So maybe I create a temporary stack or list or some shit like that. Throw all the elements in there as I'm popping it out, and then that will give me the element. But since I'm already traversing through it, I can also update the max. I think that's the answer, right? You use some kind of you use like a stack, and then you use some intermediate structure or something like that. Is that the answer?
No, that's actually the answer for other question. That is to implement a queue using a stack. Okay. That is the perfect answer. Okay, but for this problem, they're using just 2 queues.
Oh, you're okay, 2 queues.
No, actually, is 1 queue and 1 stack. Oh. But they are considering the stack just to keep track of like the elements that could be greater. Oh. Yeah, for example, like when you push an element to the queue.
Okay.
Like you will consider if this element can be greater than the others that are stored in the stack. It's kind of that line of thought. And the argument that the book did is like you will never have to traverse through all the elements of the queue because not all the elements can be greater than the greater that we found, the possible graders. So it was kind of like I didn't, even though the guys are PhDs, in computer science, I was kind of confused about this answer.
Okay, let me actually read what it says. Because my line of reasoning assumed that we couldn't use a DQ or a Q underneath a Q, because I thought that'd be kind of weird. But yeah, I can see like, okay, if I did that, then, yeah, let me actually pull it up. Give me a sec.
Actually, I guess that they are using a DAC as well, just to implement the Q. They're more focused on the part of the max,
Okay, so let me see. Yeah. So they use a Q and then they use a DQ. Yeah. So you do need 2 data structures for sure. So then, okay. So how to update DQ on Q?
You see, that is the algorithm. It's very tricky. In my point of view, I don't know yours.
Okay. Let me read it first. A brute force search track the current maximum. Yeah. So that's you can with the brute force. However, updating the current maximum is DQ is slow because you have to look through every single element. Correct. Is an element Q that has the property that it enters the queue before late element B, blah, blah, blah. Okay, fuck. I hate it when they do this shit. It's like, I don't fucking understand the fucking, academic talk for this shit. It's fuck.
They're used to write papers, not books, man.
Since S will be DQ before B, S can never be in the future because it's a maximum element stored in the queue regardless of the subsequent NQs and DQs. Okay, fine, that's fine. So whatever you put in, whatever if it's the maximum, then whatever happens doesn't matter. Okay, fine. The key to a fast implementation with a queue with max is to eliminate elements likely for. Okay, yeah, that's fine. Do is maintain a set of entries in the queue and have no later entries in the queue. Oh, Okay, so elements in the DQ will be ordered by the position in the queue. Oh, I see, I see. So I think
See?
what they're trying to say
Uh,
is that you're gonna queue things until the maximum, until a more maximum element is found, and then you put in the DQ, something like that, right?
yes.
Okay, I'm gonna tell you right now. It's as long as you
It's
can
kind
do
of
it.
simple idea.
Yeah,
Yeah.
I get the idea is simple. And I understand where they're coming from. As long as you get to the point of like using two data structures, I think the interviewer would step in. Is like, okay, can you do this with two queues, like a Q and a DQ? I think the interviewer would, like, you saw how I walked through the reasoning. The interviewer would probably say something like, okay, well, suppose that you could use a queue. What would you use? And he would say, yeah, you're probably gonna use a queue, and then I'd be like thinking about that. Um, and if I use the queue, then I want to avoid using the, iterating through every single element to find the maximum. So which means that I need to have recorded the maximum to begin with, but then what if I find something bigger later on? So then that's where the second um, data structure would come in. So as long as you got to the point of, hey, I know I need to use two data structures, the interviewer most likely would have thrown you a line. I think that's the way to think about this. Because it's not
Because
really.
I will kind of lean more to the to use to like a queue, not
Yeah.
a tree. I think you're right.
Yeah, because the tree, I think the tree is where you kind of like fucked up. And then you should have thought, okay, well, it has to be much simpler than this because this is way too complicated. I think just acknowledging that is already going to be very good, but I don't think you did that. I think you just kind of threw your hands up.
No, actually, I acknowledged that was complex. I tried but I was kind of blind.
Uh huh.
I was not seeing what can be better. I don't know, maybe lack of training in this kind of problem. I don't know.
It's a
When I
possible
saw the
elimination.
solution, yeah.
I think it's possible elimination
Go
because
ahead.
again, if you can acknowledge that it's like not simple, that your solution currently is not simple, and there has to be something better. That's pretty good, right? All that you need left
Yeah.
is to really have. I would tell you, I would not be able to come up with the two Q solution. I would probably get pretty close, but then I would need an interviewer to nudge me. I think that's kind of the key here. But then let's say that now that you have the DQ and Q, you should be able to finish the problem. So you
Yeah,
kind of saw like
probably,
how I saw
probably.
that. Oh yeah, well if I'm forced to use a Q, then I kind of went through that logic. So
Yeah.
as long as you could do that, that's
Actually,
fine.
go ahead. Sorry.
I was gonna say like as long as you can do that, yeah, like after that nudge, I think you did it. That's fine.
Good. Nice to hear. Actually, just let me do one comment here.
Yes.
There's one question that is to implement. I think is interesting to implement a queue using a stack.
Okay.
So I think that question like go in the direction you went.
Yeah.
I went in like, okay, as long as I have to pop all my elements to get like the first element.
Uh-huh.
I will have like to push all of them again to the original stack.
Yeah.
But the tricky part was because since like kind of we need to use we're gonna have to use both stacks. They're using like the same idea as you did, like one stack just to enqueue and the other stack just to dequeue.
Yeah.
And I think is a thing that I have to add on my set of tools.
Yeah, it's not. It's so like the way I just thought about it was just process elimination, right? Based on all the data structures that I have, tree has to be eliminated because I can't preserve the ordering. So it has to be like some combination of stacks and queues. And I just eliminated queues because I kind of thought it'd be cheap to input a queue with a queue. I thought that was like the problem where the problem was heading. So that's kind of like why I was thinking it. But then, like I said, the interviewer would have to step in and say, hey, what if you could use a queue? So
Okay.
yeah.
Just one more point about like the beginning of the problem. You said that I was kind of cheating.
Yeah.
What do you recommend in the end? Like, for example, I was the first thing on my mind was to use a deck.
Okay.
Do you think it's like good to ask at first? Do you want me to focus on this max problem, or do you want me to implement like from scratch? Do you think it's like a good thing to ask in the beginning,
I think
or the interviewer should tell me?
I think you shouldn't be asking that. It's up to you to set the guidelines and how you want to proceed with the problem. And so if there's a detail that seems kind of weird or kind of really strange, then it's up to you to clarify. That's what we mean by clarifying requirements, right? And so
Yeah.
for me, the weird thing is like, okay, I'm asked to implement a queue with a max operation, but then why don't I just use a queue? You see how that kind of seems like a little bit cheating? Like I think there might be something wrong here because if like the problem cannot be that simple, you know? It's like, why not just use a queue and then just hold the max of all the elements I've ever queued and dequeued? You see kind of like how that's like seems a little bit too simple or something like that. That's probably where I
I
would.
see.
It's like having that instinct of like, hey, something seems a little funny here.
Yeah,
Like, why
yeah.
would I
Like
ask?
like yeah.
Go ahead.
Like in the Microsoft interview, like to split the string, you know.
Right.
And they said, okay, now you're not allowed to use the split command.
Yeah.
Now, yeah, just implement your split. Yeah,
Exactly. It's
the
like
same
if you want,
situation.
it's like what? How do you would you split a screen? I just use a Python split. You know, and like you see, like that's kind of fucking weird, right? Like,
For sure, for sure.
yeah.
Not testing anything, yeah.
Exactly. It's like, are you sure this is like, it's just having that instinct of saying, hey, wait a minute,
For sure.
this is an interview, you're testing me. Is that really right?
Oh, yeah.
So
Yes.
I think as long as you
Good.
have that instinct, I think you could be okay. And then I see you also have
Okay.
a redo of the lowest common ancestor when nodes have parent pointers.
Yeah, that one, like the main portion here that I messed up, I think I was not knowing how to use this parent pointer. Like, how can I leverage this fact, you know?
Yes.
Well, maybe that was because, I don't know, I was kind of, I don't know. Yeah, I don't have any excuse to this.
Okay.
I don't know why I went in this direction.
Okay.
And yeah, and then I implemented like the normal lowest common ancestor.
Okay.
But yeah,
Did you
that
look
was
at
the
the
main
book?
point. I looked at the book and let me see here. Um,
Yeah, I don't see an entry in there.
oh yeah. They're kind of like doing this in place, you know.
I see.
I haven't took notes. Yeah.
Yeah, you do thought delta, but I'll try to do. I'll see if I can tell you how I would have done it or something. Okay, so 2 points of design algorithm computes lowest common ancestor. So okay, 3, 4, but yeah, parent pointer access. Okay, so your first approach here is to do a 2, 1, 3. So you're like I guess a DFS, and then you find the two nodes, and then when you find the two nodes, you do that typical compute. You do the typical computation of like, oh yeah, like in the case of 3 and 4, it's left subchild, right subchild, and then that'd be 1. If it's the same node, then you found it. If it's like 1 and 3, or then 1 and 4. I think that's basically what you're doing, right?
Yes.
Okay.
Yes.
So then the inefficiency is that you store a buffer for extra further reading. Yeah, because you're computing left side or right side. Okay, so then the question then is like, okay, well then I'm not really leveraging the parent pointer here. Yeah, so there is an inefficiency because you do have to try to find elements in the left-hand side first, and then right-hand side first, and then bring that up and bubble that up.
Yeah.
So then my first thought would be like, okay, well, can I just simply start from the child node themselves and then work my way up, find the path, and then find the overlapping path? That would get me to order log n time actually. But then I'd be using log n. No, that would get log n time because of the height of the tree, and then log n space.
They're saying that the time and space complexity to compute the depth, all of h that represents the height.
Yeah, that's log n because n's the number of nodes, so log n must be h.
Yeah, the number of nodes of the tree. You're right.
Right. So then the space would actually be height of the tree. So the thing is that seems a little too easy, and so I feel like log n is the correct time, but then how do
No,
I get
actually-
space with us in place? You know.
Actually, the space, like for the optimal solution, is all of n because you're just traversing. You know, you're not like storing nothing on the call stack. So
Yeah.
it's
So
all
but
of
should
n.
it be order? Should it be order h, not order n?
They are like iterating, you know, because they're not storing nothing.
Oh.
It's very explicit here. Is all of one.
Yeah. So that's what I mean. Like my instinct is saying, okay, because I'm storing the path, I can't get faster than log n, and so the optimization must come from space. So I must be able to do this in place somehow. So that's probably how I would have thought about it. And so let's see where your thought delta is. Your thought delta inefficiency, yes, extra buffer, traverse. Is this this code that you did? Is this okay? You just basically did the normal top down without using the parent pointer. Okay.
Yeah, I kind of gave up
You gave
about.
up. Okay, that's fine. So let's see.
Kind of,
Go ahead.
kind of gave up of trying this idea because at least I solved the problem, as Edbert said.
Yeah.
Rather than try to like, yeah.
Okay, that's fine. So
Not go anywhere.
let's see how we can get from was it your bottom up solution from going from parent pointers. Let's see how we can actually get there. So I'm gonna try the problem out before looking at the book. So let's see. So if we are basically storing the paths, then what we should be able to do is just like do it with recursion, right? Because if we consider like doing the top down lowest common ancestor, that's pretty much what we've been doing, right? You would basically record the path of the root to the found nodes and then do the overlap. In this case, it's just that, but in the opposite direction. So the question then becomes, well, how do I recursively do that? So then what would happen is I take from 3 and I go to 1 and I go to, and then if this node was visited, or if the child, let's say I come up from the left hand side, right? Then for the 1 to be the lowest common ancestor, I would have had to find 4 on the right hand side. And so in order for me to do that, then I need to traverse through the right hand side. And if I find the node in that right hand side, then I know I found my lowest common ancestor. So this would be order time n, but then this would be space of 1. So actually, I get worse time on this one. Wait, is this wait? Is this tree guaranteed to be sorted?
Hold up, let me just check.
Because if I'm guaranteed to be sorted, then I think I can get close to 8. I get close to H.
It's given 2 nodes in a binary tree, design an algorithm that computes their LCA, assuming that each node has a parent pointer.
Yeah. So I actually get into H. So I actually get like what's it called? I traverse through height H, right? And then for each one, each node of H, I do H lookup, right? Because I can go down the binary tree and look for the node. So that gets me to time of H squared actually. But I get the space in 1.
Worst. Yeah.
Yeah. So I'm like, it's not. Okay. So then the question now is, how do I eliminate that? So then now I would have to. Yeah, no, fuck. It's not obvious to me, actually.
There's a hint. The problem is easy in both nodes, if both nodes are the same distance from the root. So I think it's the point you make.
Now the problem is easy if I go through. So it's like if I. Oh, shit. Okay, I know what you're talking about. Okay, so it's like if I. For each node, I go up. And then if that node has been visited, then that's the node by both of them. Then that's the node I want to stay as the common ancestor. But then that still gets me to order H of space because I have to keep track of whether or not I visited or not, right? Yeah, because you need space to mark when it's visited.
Yeah, because you don't have a flag inside of the node. Yeah, you're correct.
Yeah, so I'm like, okay, let's see what the book says. Fuck. I'm like, it's not obvious to me, so let's see what this says. What's this called again? The lowest common ancestor.
Yeah, well, it's 9.4.
9.4.
Compute the, yeah. Yes, I'm a Brazilian goldfish.
You're looking at the chat as well.
Sou brasileiro. Yes.
Okay. So lowest common ancestor with a. Okay, let's see. So we know the common ancestor, namely the root, and nodes are the same depth. We can move up the tree in tandem for both, stopping at the first common ancestor. Yes. However, if they're not the same depth, we need to keep track of. Yes. So you need to figure out which ones you have seen, but we can circumvent storing the nodes by ascending from the deeper node to get the same depth. Oh, I see. So you calculate the height of each, and then you move up the node that is of lower height, right? And then you transform it into like moving them up until they collide. Okay, now I see what they're doing. So the same height one was was fine. That's very easy because if they're the same height, then if they have a lowest common ancestor, then they will converge at the same node. But then if they're not the same height, then you just move the one node into the same height. Okay, that's obvious. Fuck. Yeah.
And like they
okay,
collide,
I see.
right?
You
While
just
they're traversing.
yeah, you just transform the problem into a type of problem that you have seen before. Fuck. Because you know the answer. You know
Yeah,
the
I
answer
did.
is that. Okay.
And here's a question. Like, on your opinion, what do you think about it? What would you do?
Honestly, this is fair. Like, if the interviewer asked me this, they would have said, okay, I think the interviewer, if I was judging my performance honestly, I think the interviewer would have given me a thumbs down or a mediocre. It's like I got to the, I knew like I got the answer pretty quickly, but then it's like the fact that it didn't get obvious to me, and I needed the hint for the height, I probably would have failed myself. And it's like, he needed some hints. He didn't do quite well until I told him how to like massage the problem. So he might have given me like a borderline on me, if not fail me.
I think about the same because I thought about myself. Well, the interviewer can ask me, how can you leverage the fact of the pointer? What's the point, of having a node that you're not using? So you must come up with some algorithm to use this.
Yeah.
I was pretty mad about this one.
I mean, it's a good lesson, right? So it's like what a new tool can be like, can you massage the problem into something that you know works? Because again, like you already know that elements of the same height already work. So then all I'll do is like, okay, what happens if there's elements of different height? Just move up the node to be the same height. Okay. So it's a good tool to learn. It's a good lesson, I think. And so the delta here would literally be, can I get to a state of a previously known solution?
Okay, I think I'll redo this problem actually.
Yeah. Other than that, I think what we're doing right now is fine. All it is just like these one-off things, like okay, what's the tool, what's the delta here? But if you're consistently getting problems right and a pretty good time, then I think you're fine, and you're on the right path. Let me take a look at your Let me take a look at your sheet just to double check. Okay, so it seems like your times. Wait, what's your serialized and deserialized times? Your times seem to be okay. Delta between the books, well-structured code. Floyd-Torres algorithm here. Ignore the Floyd-Torres algorithm shit. It's getting crazy. It's shorter but not quite intuitive. I would say for this row 235. Yeah, I think you want to do a better explanation.
Because they are using. That was. Let me check here. Which problem is that? Repeat the binary tree in order of increased depth.
Okay.
I don't remember by the top of my mind.
Yeah, you need to check. Why is it shorter? What do they do that was shorter but not quite intuitive? Why did you write this comment? That's more important.
I think I'm not gonna guess, but sometimes when I write things like this, it's because they are doing in a very Pythonic way, like just.
If it's just very Pythonic, then ignore it.
Yeah, I'll just double check.
Okay. Anyway, I think you're on the right track. I think definitely keeping a little timing yourself a little bit. Okay, let's see. 40 minutes for this one. Bad. Implement a hash map. This one is a red flag to me. Anything that's above 35 minutes, I would say. Definitely try to figure out where you went wrong. Yeah. I think anything. The benchmark should be like 35 minutes. So it's like. And this is fine. Like you see, like 245 is fine. Like the 245 is fine because you took 35 minutes and you solved it. That's fine. 36 minutes. Okay, that's fine. But like when you start getting to 40 minutes and it starts to be an eyebrow.
40 minutes.
So
okay.
I would definitely look at these. Other than that, I think you're okay.
There's one point here. Like when I start a question, with the mindset of, okay, let's try to make this happen in 35 minutes. If I just start with this thought, I got in the same mindset of like doing a lot of mistakes, But if I start a question, just okay, let's try to have a conversation with myself, just explain as if I was explaining to Edgar or my friend.
Yeah.
I think my answer is much more concise and clean and like correct.
Yeah.
Correct,
Correct.
Yeah, so, just the point I need
like
to
I said,
understand.
going into the problem, don't worry about the time. Worry about the time on the review. But going into it, just let where the chips fall, they fall, right? We want to make sure our approach is absolutely good, and we want to optimize that approach. We don't want to cut corners. We want to make sure our approach is rock solid and efficient. and then we use the data after we've used that approach in order to try and improve it. So don't worry about the time going in. Worry about the time when you critique yourself.
Okay, it's just inverted.
Yes.
Okay,
So
I'll think about it.
that's all I got for you. I think the path we're on is right. I think that you still have all these problems here, so that's fine. This should take you a while to do, so I have no problem with what you're doing here.
Okay. Oh, and just to keep you posted, like about the other companies.
Yes.
One of the Netherlands,
Yeah.
they are kind of move forward, move like with me in the process, you know.
Yeah.
Like, and the other two online assessments, one just reject me straight away before I even do the online assessment because I was not a Canadian citizen,
Okay,
and they're
okay,
not
we
willing
can't
to
do anything about
sponsor me.
that.
And the other one, I did on the Sunday, or Sunday or Saturday, I'm not sure.
Yeah.
But they haven't like replied me yet. Both of them from Netherlands actually.
That's fine.
Yeah.
Okay, don't worry about the Canadian one. You weren't born Canadian. Not your fault. Nothing to do about that.
Not my fault. If I was, if I can, much better. Yeah.
Other than that, yeah, let me know how the online assessments go, and we'll take it from there. Yeah, 17 days, man. Let's make it happen.
Man, I'm pretty sure. I'm giving my best. And by the way, I read the book Relentless. Pretty good, by the way.
Yeah, it is.
Recommend.
Yeah. Yeah, so good luck with that, and I'll see you Saturday.
See you Saturday, man. Bye.
Bye-bye. All right, cool. I guess that's it. I'll stop the stream since there's no other questions. So yeah, we'll have something on Saturday, 11 a.m. Pacific Standard Time. So yeah, thank you all for joining me. I guess we will spend our time there together. And hopefully this guy, he pulls through. We got 17 days till Microsoft. So let's see what happens. So thank you all for joining me. If follow me on my socials, link in the description down below. Yeah, and if you guys want to join the Discord, I'm very active on there, and I'll answer any of your questions. So until then, thank you all for joining me, and I'll see y'all later.